Welcome to the video for section 1.4, and section 1.4 is about inverse functions and relations. So we'll start with an inverse relation. So remember we talked about relations earlier this year. Relations are just relationships between one set of numbers and a second set of numbers, an input and an output. An inverse relation happens when if one relation contains the point A comma B, the inverse relation would contain the point B comma A. So the key idea here is that the coordinates are going to flip when we have an inverse relation compared to the original. So here's some examples. We want to find the inverse of the following relation, and then we want to determine whether or not each relation that we come up with is a function. So here's the first set. Currently, this relation is a function because each x coordinate shows up only one time. So now to make the inverse, all we're going to do is we're going to switch my x and my y coordinate. So instead of having 1 comma 4, 4 comma 1. Instead of having negative 2 comma 5, 5 negative 2. And so on and so forth. 4 6 becomes 6 4. 8 11 becomes 11 8. And 3 7 becomes 7 3. Now for this new inverse that I just wrote in red, do any of the new x coordinates repeat? No. So the inverse relation is also a function. Let's try the next one. Okay. Again, I have a function because each of the 4x coordinates here in this relation are unique. They don't repeat. Now let's come up with our inverse. Okay, so we'll flip-flop. Now we have 2 negative 4. 0 negative 3 becomes negative 3 comma 0. 1 2 becomes 2 comma 1. And 4 2 becomes 2 comma 4. So there's the inverse. Now is this a function? Well, look at the new points that I've created. I've got 1, 2, 3 points that all have the same x coordinate of 2. So no, the inverse is not a function. And that's important, and we're going to talk more about that in class. Sometimes functions have inverses that aren't functions, and sometimes they do. Okay? So you have a couple examples in the notes that I want you to try. So pause the video at this point and give those a try. Now let's look at inverse functions. So this time, both the function and its inverse are going to be functions. And I want to show you the notation for that, and it's right here. So f of x, that's our new y equals notation that we've been using this past, few weeks in class together. Now, to express an inverse, we're going to write f with this little minus 1 as an exponent. That's not how we read it, though. We say it's f inverse of x. That is the symbol for the inverse of a function. Okay? All right, so now let's try to find some inverses algebraically. So instead of given a set of ordered pairs, I want to start using the equation to find the inverse equation for the given equation. So simply the idea of that is you're just going to exchange the y and the x in the equation and then solve for y. So in this first example, we have f of x equals 2x minus 5. What we want to try to do is we want to find f inverse of x. Okay, so first question, how do I solve for y when there is no y? Oh, I remember we talked about this earlier. F of x is the same thing as y. So why don't we rewrite this as y equals 2x minus 5? Now we can crisscross and flip the x and y. And as we take our inverse, we can now rewrite the equation as x equals 2y minus 5. And then from there, we can use all our algebra to solve for the y. So all the stuff that we're used to doing, we'll do now. So I'll add 5 to both sides. And I get x plus 5 equals 2y. And then I'll divide the whole thing by 2 to undo that 2y. And I'm left with y equals 1/2 x plus 5 over 2. And I can put my f back in, but this time I need that little minus 1 for inverse. So f inverse is 1/2 x plus 5 over 2. Okay, let's try that again with this second example. So f of x equals 4x minus 6. Again, I don't have a y, so I got to put it in place of the f of x, because that's the same thing. And now I'll go take my inverse, so that's saying x equals 4y minus 6. And we can solve for y, so we'll add 6 to both sides. X plus 6 equals 4y. We'll divide out the 4. So now we have y equals 1/4 x plus 3 over 2. Because remember, 6 over 4 can be reduced to 3 over 2. And then putting our inverse back in, f inverse of x, we can also say is 1/4 x plus 3 over 2. Okay, in the notes you have a couple more examples like this to try. We'll be doing more inverses in class. Thank you for watching this brief video. If I went too fast, feel free to rewatch some of the examples and ask me questions in class. Thanks again and have a great evening.